Thanks, and I'm actually going to do this as a tag team because I think you've seen me a lot, so I'm going to also have Shiyu Wong who's going to do a little bit of the presentation. And she has her PhD in Grasslands Science from the Mongolia Agricultural University, spent a year working as a postdoc with Walter Wilms, and then got sidetracked with the bright lights of annual cropping, but has come back to her passion of grasslands to help us work on some of the carbon stock change issues. So she'll be coming up at some point. So we have this challenge. We have to do a national greenhouse gas inventory. Canada does every year. It gives our greenhouse gas emissions and removals. That includes our agricultural land has to be included in that. And we have to follow the Intergovernmental Panel on Climate Change, so they have good practice guidance that we have to follow. And there's this concept of tiers or levels of estimation. So the simplest is a tier 1, is simply kind of default methodologies that can be applied anywhere in the world. And then what is countries are encouraged, Canada generally does this for most of our emissions. We have some what we call either tier 2, but it's really very country specific emission and removal data. Or we go to what's called tier 3, which is a really sophisticated modeling or survey-based methods. But we really want to try to move all our greenhouse gas inventory, at least for major sources and sinks of greenhouse gases, to tier 2 or tier 3. One of the aspects of good practice guidance is that Canada has to divide its land into 6 classes: forest, cropland, grassland, settlement also including things like transportation corridors, wetlands, and then other being anything that isn't one of those. So that is one of our first challenges then, is how do we define, or what do we define grassland as in our system? And what the approach that we took was, of course there's a lot of different types of grassland in Canada. Like the tundra is grassland, but there's what we call agricultural grassland, which is what we're concerned with. That's being used as grazing of domestic livestock. Then, as we decided, we would define it as grassland if it will not naturally convert to forest if abandoned, except continuing fire suppression. What in the inventory game is, you don't want to have a lot of land use change, and I was going from one of those 6 categories into another. You want to try to reduce that, and particularly you want to try to set definitions where land won't flip-flop between land uses on a regular basis. And also you want to have methods that are fairly practical to implement. And when you get into the parkland, as Jeff was talking about, oftentimes you find that some of them are being encroached by trees, and so you get this problem: is it a forest or is it a grassland? And that's a huge problem for the for greenhouse gas inventory. Hence we took this very narrow definition of trying to say, okay, we'll get out of the areas where tree encroachment will be a major issue and keep it in the more semi-arid areas. So we're really talking about essentially the brown and dark brown soil zones within Canada, and essentially it's the mixed grass prairie. So there's about 5.7 million hectares. But this relatively stable area, because we're talking about more climatically marginal areas, so that there isn't as much pressure, at least from converting it to cropland. But then it also meant that anything that didn't meet that definition of grassland that's used for agriculture is by default called cropland. So our cropland under those 6 categories we have includes an awful lot of native grass and actually the majority of our grazing land. But that's just one of the things that we had to come up with a system. So this would be the areas of brown and dark brown soils. And you can see essentially it is the brown and dark brown soil zone of the prairies, of course, but there are small patches within lowland areas. Well, not necessarily lowland, but within the interior BC. And then this is the overlay of the recently created AFC grassland mask within the prairie region, and you can see, as has been shown by others, that most of this area has been is no longer in grassland. It's used primarily, the other main land use would be annual cropping, but there still is substantial areas, particularly in southeastern Alberta and extreme southwestern Saskatchewan. So then we have these categories, and then of course then we have to decide, okay, how do we we have to get a carbon stock change on that grassland. And we said, well, that's difficult and confusing to do that on grassland. So we said, it's too difficult and confusing, so we're not going to do it. And and that actually lasted for a while, but then the reviewers said, no, you can't do that. You gotta give us an estimate, and they wanted it now. And so I think the latest review said by next year, right? Yeah, that's what they. So I mean, they've been telling us this for a little while. So we're now in a position where we can't delay it anymore. This argument doesn't cut it. And so this then really is why, as Murray mentioned, kind of the impetus for this particular workshop was then what is the state and trends of Canada's grassland, and particularly then kind of a word from the sponsor, or one of the sponsors for this workshop, is what can that tell us about carbon stock changes. So because, as I said, our definition of grassland and our needs, we're kind of an immediate focus is on these natural mixed grasslands, because that was, we said that's kind of what we define grasslands, that's missing. But of course, we need carbon stock changes for all our grasslands, so it's not just in that narrow definition. And in the sense, in a way, because the others are called cropland, they are being included. They're not really being estimated in carbon stock change, but effectively we're saying there is no carbon stock change on any grassland outside of that grassland area that we define for greenhouse gas inventory purposes. So a confusing thing, but I mean, I guess it's. But I said, I think we have this immediate focus on a particular aspect of our grasslands, but it's not to say that we're not and don't need to deal with the other parts of the grassland. But I also think we need to think too about, what could this kind of quantification, what other benefits could there be from that? And certainly one of them is this whole issue of environmental goods and services. So, we know that these are very important for grassland areas, but how does society reimburse the land stewards for these? And then this is where the greenhouse gas aspect for offsets really becomes sort of the first example of how you build a system that actually starts paying for at least one of the environmental services. And so it's important to sort of get some of this quantification right, because it may and probably will inform how in a large system for environmental goods and services is dealt with. And certainly we have the Alberta provincial offset system and the emerging Saskatchewan system are ones that are certainly interested in this, and but he said it's probably a case where you can use this beyond that. And also, of course, beef production, which is, of course, what a lot of these grassland areas are being used for, is under challenge. But as this in Liebig's famous paper is that because carbon change in that particular study was so large, was overwhelming other emissions, that in fact you could produce the calves coming off the grass as carbon negative, actually, saying it's a net sink to be producing calves, which wouldn't be the case if you were producing crops on that. So that's not the entire life cycle of the beef production, but it does well to point out how if we can get this right, it certainly has important implications for the beef industry as well. So how does Tier 1 work? I'm not going to spend any time. There's sort of an equation. There's a number of factors that relate back to some soil organic carbon level. There's also biomass and dead organic matter. Those are more just less on a kind of a stock change or loss gain basis, the carbon stock. So organic carbon is more complex. It has a number of factors. There's a table in the 2006 revised, or 2006 guidelines. Covers the latest version of these numbers. So one main factor is it says if you're nominally managed a grassland, then it's a default of 1, which means there's no change in carbon. So as our land nominally managed. If it's moderately degraded, then it's 95% of that reference carbon stock. Do we know that? And then if it's severely degraded, it's 70% of carbon stock. And then there's some different improvements that can be put on, but that's not so relevant for native grass. So how do we implement this IPCC? How do we determine the area of moderately severely degraded? And again, these definitions have to be matched. You have to have a carbon stock change to go with your definition of of degradation. So in a tier 2 system, if it's country specific, you've got to match this up. So you've got to have sort of both things. You have to know what the carbon change is for how you classify your situation. But the thing is, though, we're not really in some ways interested necessarily in the state of the grasslands, because really the purpose of all that inventory is in many ways is to capture what they call the direct anthropogenic emissions. So what is coming directly from human management. So it's not the focus on weather and natural disturbances. Obviously there's huge interactions between human management and weather and natural disturbances, but it's really what is that part that we can really relate back to human management. And also there's indirect anthropogenic, human-induced climate change, but not so maybe important in the Canadian prairies, but many grasslands in the world, atmospheric end deposition. But again, how do we get this deliberate human management? So is there alternate ways that we can quantify greenhouse gas emissions based on human management directly? So we have sort of a conceptual model of that if we have a grassland, that if we graze, I think you can primarily use grazing as our main human management. If we graze most of the grass, then we don't have any litter, and it's very poor, and there's very little growth. And if we don't graze much, we get big litter layer, lots of growth, lots of roots, so we get lots of soil organic carbon. So that's sort of a conceptual model then, how it works. So how does that match observations? There's some in the literature, there's a number of reviews, sort of saying that's generally inconsistent. There's certainly implications that you can pull out from a large number of studies. It says nitrogen is important, so we can retain N, we can increase soil organic carbon. The length of time is important, so the longer you go, the less likely, at least in this set of studies, mostly from Western North America, the longer you go, the less likelihood you see a change from grazing. And another study, again, inconsistent effects of soil organic carbon from grazing, but certainly there's demonstrable effects on annual net primary production. And then you start looking at some individual studies. And you can see a number of studies here, and some quite long, but really saying there's no difference. I can't detect a difference between grazing pressure, particularly no grazing versus grazing, so a lot of exposure studies. And you can find more studies saying the same thing, that even fairly lengthy studies, there's just really no evidence that grazing at all is really affecting the carbon. Then you start to get a number of studies, you start to say, okay, yes, we can't detect a difference statistically, but there's starting to be a trend that as I go to grazing, or particularly where heavy grazing, heavy utilization, then I'm starting to see a trend that the grazing is lowering carbon, which is sort of our conceptual model. Then you start getting some that are starting to confirm statistically, say, yeah, so I don't have any grazing, I have more carbon than if I had grazing. And then this study starts to show across the gradient of grass types and climates in the central U.S. That starts to show there can be differences or interactions with the grass types, so it depends more or less. So we're starting to see now either both confirming our conceptual model, but also starting to flip the other way to situations where grazing now is increasing carbon. And then you start moving towards more studies. These are repeated studies on the same experiment after two different periods, where you're starting to see grazing effects that aren't necessarily consistent. And then we start getting to a range of studies which are really showing that grazing is having more carbon than no grazing. So remember, our conceptual model says this shouldn't happen, but we're starting to see a number of studies where this is starting to happen, where again you've got some situation where one particular grazing system is having more carbon than no grazing. So whether that's heavy or light utilization, of course these definitions vary among studies, but so this is, I guess, why in those worldwide literature reviews, again, you often find that a statement that the effect of grazing is inconsistent. So we can look a little bit at range condition, and this is, of course, not range health, but it's sort of the older range condition. A few studies that have sort of compared, again, some of them are actually no versus grazing, but no difference. One from Romar and Wilms, where because of species shift, actually the poor condition had more carbon than the good condition. What about introduced species? So there's a number of studies that particularly deal with crested wheatgrass, whether it's invaded or actually was intentionally even seeded. Quite many of them are quite long-term, quite consistent that there's no real effect of crested wheatgrass anyways coming on to native grass on the effect of soil carbon, intentionally seeding alfalfa. Yes, that's a very large increase in soil organic carbon. In fact, gains of 1.5 tons of carbon per hectare per year initially, so that's very, very high rates of carbon sequestration. Burning, we couldn't find so many studies, but one in tall grass, burning caused loss. One in Alberta, burning caused increase. So organic carbon. What about shrubs? Here, definitely ecosystem carbon goes up. With shrubs, obviously there's a lot of carbon associated with the coarse woody biomass in the shrub as well as in the coarse roots. That's much different than grass, but even the soil organic carbon is it's at least equal, if maybe not any higher, in the shrub area as opposed to the surrounding grass that doesn't have shrubs in it. So then how does our conceptual model work? It doesn't seem to be working too well. Nomar says in native grassland, and one of his very resilient grazing pressure with regard to total carbon, and so I almost think it's maybe more I call kind of resistant soil carbon conceptual model, in that it does seem to be that it's resistant to change, and so it takes a long time to get to see change, and it may not be a lot. There may be plateau areas, in other words, you can have some utilization, and you really won't see an effect on carbon. But generally, I think there is. I mean, there are cases where, there's probably cases, and it seems in the literature anyways, even for the long term, there may be cases where grazing actually maybe stimulates growth, or the whole nutrient cycling is improved, or there may be improvement. So, but I think instead of that very drastic sort of close relationship between grazing, these interior vegetation utilization, and so we get carbon resistant model might work. One of the things that we have is what will carbon change over time? We don't have a lot of information on that. And that's one of our big things. There's some relatively short-term flux measurements that, yeah, sure, obviously different times of the year, different weather conditions, the particular grazing things can be a source or sink of carbon, but there doesn't seem to be any evidence that grasslands are a consistent sink or source of carbon, nor there's a consistent effect of grazing. And then this, again, this Liebig study, the one that suggests that that grazing on some native grass can be carbon negative, is really based a lot on the fact that it had some historical archive samples, and this is on native grass management and constant since 1916. So even in '59, it was a long time after these grazing regimes have been imposed, but reporting really, I would think almost impossible to believe. Carbon sequestration rates on this native grass, almost half a ton of carbon per year, though again, a lot of it is related to species shift, particularly the blue ground. So about N2O, and so methane consumption, anything we do to affect carbon is going to affect nitrogen, that's going to affect N2O. The cattle, of course, their urine patches are an important source, so anything we do that affects the number of cattle or what they're excreting is going to have an impact, but it doesn't seem to be a lot of clear information on this. And also N2O consumption, the rates are often small enough, and N2O consumption also needs to be included. For methane, it's grassland soils are pretty much, our net consumer. In other words, they're pulling methane out of the atmosphere and consuming it. And so this can start to become important, especially when you get lower stocking rates. In the Liebig study, about a third of the enteric emissions while the animals were grazing was actually thought from their measurements was being consumed by the soil. So that's an important thing. So now I'll ask you to come up and talk a little bit about what can we learn from other areas of the world.
Thank you very much. So continue with the example in North America. I'm going to talk a little bit about the grassland carbon change on some other part of the world. And I'm going to focus on the same area called temporary, the grassland in northern China. So here I summarized some literatures published in the last 10 years in terms of the grassland carbon change affected by the grazing management. And it's a little bit different from North America. And in China, in all these three grassland typical meadow and the desert steppe, we compare the continuous grazing with grazing inclusion, and we also compare the grazing intensity differences, and we got the general trends for these two trends, and the carbon will decrease along after the continuous grazing, and it's also decreased with the grazing intensity increasing. So this one is I summarized some species switching after the long-term grazing effect. So it's obviously the species richness and the diversity will decrease after long-term grazing. So yeah, so that's this model, this carbon consumption model is also suitable for the Chinese grassland as well. So here, I'm going to show some pictures of where I used to working at. This, we can easily see the differences between the different grazing intensity. This one is in the typical steppe in Mongolia, and this one is the different landscape of the grazing intensity on the desert steppe in Mongolia. So here, these are the comparison of about the diversity in the previous and in the current, and we can easily tell there's lots of species lost after the long-term overgrazing. So after the long-term overgrazing, the grassland will degrade for sure. And in the middle of this picture, you can see the sandy area patches showed up in the grassland, and finally they will keep expanding and turn to the sandy area eventually. So that's even worse. The sandstorm is very popular, and it is a very famous in the western part of China. So facing to these situations and problems, what kind of challenges we are facing to and how to solve the problem? So the first two questions will be the most concern of us right now. The first one is the carbon storage estimation, the state, and another one is the carbon storage change on time sequence. That is the trend, or we want to see the carbon change in the last 20 or 15 years. And we want to know the grassland is a source or a sink, and how it looks like in the previous year and how it's going to be in the future. So in this part, we need to integrate the climate change and management in it. So here I summarized some challenges we're facing to, and I'm learning, and I want to share these challenges to everybody here and discuss. So the first challenge is where the grassland exactly located. So we need to define our research area and what type of grassland we are going to focus on. And the challenge two will be the grassland management history. So we know the grassland management history will be the most important part to affect the grassland carbon change in the long term. So we need to know the grazing animals or the stocking rate, distribution, grazing years, or the grazing system like deferred rotational and seeded fertilizer, all the management. But as far as I know, I think we are still lacking of this kind of information in both Canada and in China. So here to solve the problem, but although we are facing to this problem, and we still want to know the state and the trend. So there are two ways to solve the problem. The first one will be the direct way, and the second will be the indirect way. So the direct way is like the traditional actual measurement, like the basic grassland survey, like consulting with the sampling method. But there is a problem with, like in Canadian prairie, it's a big fragmentation and many patches on that, so it's very difficult to do the large scale sampling working on that. And there's also the way we need to calculate the time and labor and the money cost. And another problem is we are still lacking of the carbon data in the previous years. Because we don't have this kind of data, so it's hard to get a comparison to the previous years and to know the trend. And this one is the indirect way. So I summarized the 3 ways to make it possible. The first is remote sensing and modeling things, or the integrated approaches. So this part, I think, is the most methods that people are using right now, but it's still a lot of the problem we need to figure it out. Like the modeling things, the validation is a really important thing.
So, like one of the areas then, there's potential is using different vegetation indexes and relating that to carbon. And so this is some work that Julie and Ted have done, and actually Julie has a poster out there. But it just shows that if we start at 88 and go to 2012, that actually our grasslands, and this is in both semi-arid and parkland areas of Saskatchewan, the NDVI has been increasing over that time, despite droughts and whatever, which is interesting, and that includes includes both community pastures, PFRA or ASAB or AFC community pastures, which will soon be gone, as well as the surrounding grassland are both going up. And of course there's lots of literature that would show in a general sense there's carbon stock goes up as NVDI goes up. Obviously NVDI is representing kind of vegetative growth and hence related then should be carbon input, so there should be this relationship. So that is certainly one area then that part of that integrated modeling could be really useful. And I guess one of the big questions is there sort of a grazing sweet spot? Is there a place, and this is a question I guess for us, is it sustainable, is economically viable, and also favored? In other words, is it the one that people want to gravitate to? And then from our perspective, greenhouse gases increase as so organic carbon also does to satisfy other environmental and social goals. And so we want to have a categorization system that can make sense for all these outcomes that we want. And we probably want something hierarchical. We want to capture management history type. And I guess this is coming out of the China famous researcher in Grasslands said we want to find that approach, and this is part of this categorization, this quantification is an approach to reach a balance of ecological, social, and economic goals. This naturalized grassland is an interesting one because I mean obviously we're talking about pastures established on once cultivated land, so obviously there's a lot of knowledge about carbon stock changes when you make that conversion back to grass, but of course it's going to depend then on what are the states when they were converted, how long have they been under grass, what are the plant communities and whatever. And I guess a fair bit is known. Ellen Owasa and I have been working on one. We do know a lot, don't we? But anyway, but there's a lot known there, but it certainly is a certain type of grassland where you would expect carbon to be increasing. And so that's sort of one of the things. So to sort of put it all into perspective, our concluding thoughts were that we've got about 12 months and we have to have at least an estimate for grassland. So that's certainly the challenge that we've got, and we're handing to everyone here and ask us. So the big question is, are our grasslands a greenhouse gas source and sink? I don't think we know that, but we have to. So we have to come up with an estimate, or an estimate with uncertainty bounds, would be the way to put it. And also, and how do we best estimate whether it's source or sink? So we have some short-term things. What could we do in the short term? How do we build something in the longer term that will provide a better basis for managing our grassland? And again, whatever these quantification techniques, we want to support other objectives, and we want these to also help support in a general sense to find, or I believe anyways, if we can build all of these systems of categorization and monitoring and whatever in ways that help us reach a stable sweet spot, then we've obtained real value out of our investment. Thanks. Quick question.
question on soil carbon estimation, greenhouse gas work?
Is it fair to say that the literature on soil organic carbon has an answer to the question of a big decrease from native grass cover to cropland? Is just a fact, and it doesn't have to be investigated. Is it fair to say that?
Yes, the question was, it was well known that carbon decrease is going to cropland. Yeah, it's well known, the exact amount varies, but certainly 30–50%. There's no question about that. We have pretty good data because there's a lot of cross the fence comparisons, of course, that you can make to do that kind of study, so.
So could you then pretty easily say what the value would be of converting cropland back to grassland for soil organic carbon?
Yes, yeah, and we do that now in our greenhouse gas inventory, and that's why I say that sort of naturalized grassland, something we're not really considering. We kind of lump that into cropland, I guess, but probably it needs to be considered because, I guess what I'm thinking now is even that land that was broken in the 20s for 3–4 years and then was allowed to revert back to grass, that still may be sequestering carbon at rates, given the size of the area, that might be significant overall. And as I said, when you think about the beef industry and its environmental perception challenges, all these things are important. So, yeah, there's that whole area of how to capture the complexities of land that was converted for quite a while. The recent stuff we can sort of capture because we can measure that with Earth observation, but the long ago stuff I think is still relevant, and that's more difficult for us to include.
Great. Thank you. I think we'll move on now.